In relation to Episode 1, there were opposite opinions to the conclusion that Sewol Ferry sailed zigzag. They asserted that zigzag sail might be caused by the wind or tides, etc. Therefore, Director Kim will verify his conclusion based on additional evidences, which were not disclosed in Episode 1. It's true that, although a ship tried to sail straight, her course may become zigzag due to tidal influence. Here is the data to put a full stop to this argument. This data was prepared by Korea Institute of Ocean Science and Technology, KUST, and shows the tidal velocities at the time of the accident. At 8 o'clock, the tidal velocity was only 0.2 meter per second, equivalent to 1.4 knot. At 9 o'clock, it became somewhat higher and was 0.87 meter per second, equivalent to 1.7 knot. A mate said that, for shaking a ship vigorously, 4 knots of velocity would be required. In addition, the captain of Sewol Ferry testified in the court that the area of the accident has large width, had no tide, and the weather was good. Analysis of HDG and COG reported by the government. This is the graphic expressions of the track data submitted to the National Assembly by the MOF. Blue lines show HDG and green lines show COG. The angle changes are small here. The COG significantly changes by about 8 degrees between these 2 points. The HDG is almost consistent with the COG. In this section, don't forget to remember that the COG, that is footprints, follows the HDG. S-line and zigzag sails appear. However, the COG does not follow the HDG anymore from 0845, and then they are completely separated. When looking at this section, the COG is changed by 4 degrees for 6 seconds at a time. You may neglect 4 degrees of angle change, but it's a large change for Sewol Ferry. Let's look at Oyamana test record. She may be called a sister ship of Sewol Ferry but is somewhat smaller. This is hard over performance test of Oyamana. When rudder is veered here, the ship angle is not immediately changed. Due to the influence of inertia and, as the ship is in a fluid, previous angle is maintained for a while. The angle is changed by only 5 degrees, after 15.2 seconds. Sewol Ferry has somewhat better turning performance. Sewol Ferry has 1.8 to 2 degrees of turning performance per second. According to professionals, in order to make 4 degrees of turn for 6 seconds, the crew should veer the rudder hard over, in advance. In conclusion, differently from the crew's testimonies that they did not veer the rudder exceeding 10 degrees, they must put the rudder hard over, in advance. However, the HDG shows gradual veering differently from the COG. Now, let's analyze this section. This is a section to sail to the left and then to the right, in the S-line before zigzag sailing. She turned 5.5 degrees to the left, and then 7 degrees the right. The result is return to the original angle, with 1.5 degree of meaningless angle change. The changes in COG are large but, the changes in HDG are small. The changes in HDG look to be the result of tidal influence. Don't forget to remember that this kind of COG change requires veering the rudder in advance, always. Now, it's possible for us to suspect COG to be incorrect. Let's review the process to verify the COG. HDG is shown in the right part and highlighted figures are very large because they belong to the accident section. The HDG reported by the MOF is expressed in figures in the left part and is expressed in the course of Sewol Ferry in the right part. Can you see an obtrusive ship? During the turn to the right, she turns suddenly to the left, like a ghost ship. From this position, Sewol Ferry starts drifting. So far, the government has never changed their report. Meanwhile, when I met a captain, he told me a surprising opinion. He said that, if a turning motion is made, the ship had to face the right part, rather than the left part. Let's verify the captain's opinion. There was another ship, called Dula Ace. Dula Ace received a request for rescue and is now coming to rescue drifting Sewol ferry. Let's look at the scene in the opposite position, that is on the board of Dula Ace. Sewol ferry faces Byonggang Island and, after drifting for a long time, her stern faces Dula Ace. Her stem never faces Byonggang Island. However, the film taken on the board of Dula Ace shows a different scene. Sewol ferry faces the left part. HDG is incorrect. COG is verified to be correct. Now, what shall the government do? The government had to know this fact just after the accident. They had to know this fact 4 to 5 months ago and had to say that HDG was problematic. This is irrefutable, anymore. Director Kim found a piece of information on the so-called data loss section. I found only one piece of information. It has been said until now that the data for this section was unavailable for 35 seconds. According to the government's report, there was neither power failure nor AIS trouble. And then, probable reason would be that somebody did not record the information or deleted the record for the 35-second section. Anyway, they say that the information might not be received. Of course, unstable situation may rarely occur. But, why during the very section? Anyway, I found a piece of information on the very section. This is the data loss section, that is the very 35-second section. This data was reported by News Tapa. I told you that the data from Jindo VTS was late by about 1 minute. Therefore, I wanted to identify how long the data is delayed. As shown, COG is 134.8 degrees in latitude and longitude appear, too. I wanted to cross-verify the data. Can you see Upilai in the map? If I know the real time that Upilai was at this position, it's possible to know the exact time for Sewol ferry. The AIS information on Upilai was available in foreign data. I know that the position of Upilai was highly similar at 08:49:09. The temporal deviation was about 1 minute in this case, too. I corrected the time and put Sewol ferry at the identified position. Look at this red ship. The data in blue was reported by the government and the data in yellow is foreign data. Central circles mean the exact positions. The distance between the central circles of blue ship and red ship is very short, 1/2 the ship length, that is, 68.64 meters. The temporal difference was 8 seconds. The COG difference between government's data and newly obtained data was obtained, and was 11.9 degrees. As a result, it was found that she turned about 1.5 degree per second. When I told this fact to a captain, he told, "Oh, hard over was put, and, if not, the rudder was veered at least 20 degrees to 25 degrees. Here are the examples of maximum turning performances of several similar ships. In conclusion, the rudder was veered almost hard over in Sewol ferry. This is professionals' analysis. They calculated the course in terms of ship length. The captain said that, in order to get this direction here, the rudder was to be turned 25 degrees before 3 to 4 ship length in advance. Probably, at this position. He said, at this position, the rudder was turned to port, and then, when she was sailing to the left, the rudder was turned to starboard, at this position, during sailing to the left because rudder should be turned in advance. The conclusion is that the rudder was turned hard over, intentionally, and that the government's HDG is incredible. When Director Kim met many professionals, and, when he was about to disclose his findings, the government party released a report. This is the report made by the Joint Prosecutor Police Investigation Headquarters. They said that such a large angle change might not be made and might be caused by a trouble with gyro compass. They said that the gyro compass might receive a shock with precession during a rapid turn and might have a temporary trouble. The role of a compass is to indicate directions when it turns. I don't understand that the compass had a trouble due to a turn. What about that Director Kim's surveys? How many gyro compasses of ships had troubles due to turns of ships in the world? As we obtain new data that she tuned by 1.5 degree per second, we need to identify the turning radius. According to the government's data, she turned with 2,389 meters of turning radius, but the identified turning radius is 328.4 meters. And then, the tilting angle is increased to 6 to 7 times, as shown in the picture. Tilting angle is highly important, because the accident occurred with tilting.